In this video, we'll explain and demonstrate how to utilize the FD Rapid GolgiStain kit for Golgi Cox staining.
The first step of preparing the tissue for sectioning will be freezing the brain. It is imperative to perform the procedure under the hood. Eye protection is necessary when working with isopentane solution. The materials required for this process are dry ice, styrofoam container, protective gloves, aluminum foil covered glass beaker, tissue freezing medium, braided metal rod, aluminum foil specimen disc. Optionally, you can use a plastic spoon, long Q-tips, ultra-low temperature thermometer, plastic forceps, aluminum foil-lined plastic tubes containing specimen, timer, small plastic dish, napkins, writing utensils, aluminum foil with brain ID and Kim white paper, isopentane solution, and reagent-grade alcohol. Start by pouring alcohol into the styrofoam container. Cool the temperature of the alcohol by slowly adding in pieces of dry ice. The addition of dry ice will cause the alcohol to bubble. Cover the container and allow bubbling to calm. Insert aluminum foil covered glass beaker containing isopentane into the styrofoam container. Continue to add pieces of dry ice into the alcohol in order to cool isopentane down. Again, cover the container when alcohol bubbles. Using a pair of Q-tips, stir the isopentane. Stirring the isopentane will help the solution at the top of the beaker cool by mixing the warmer solution on top with the colder solution at the bottom. Check to make sure the temperature of the isopentane near the surface of the beaker is below -70°C. Repeat the addition of dry ice if temperature is above -70°C. Remove a specimen from the centrifuge tube and transfer onto a small plastic dish. Then, place specimen onto a napkin. Gently dab napkin on specimen to remove excess fluid. Apply a small amount of TFM onto the specimen in order to fill in gaps on the surface of the specimen. Place specimen onto specimen disc and place the disc on the braided metal rod. Slowly dip the specimen into the beaker of isopentane. The dipping process should take about 1 minute, the slower the better. This process prevents uneven freezing and eliminates cracks in the specimen. Dip the specimen a couple of times, then place on dry ice for about 1 minute. Optionally, you can use a plastic spoon instead of a braided metal rod and specimen disc. Wrap the specimen with Brain ID using the Kim white paper and aluminum foil. The specimen is now ready for sectioning. Optionally, specimen can be stored in a plastic tube and placed in a -80°C freezer.
Here we'll demonstrate the tissue sectioning procedure between two cryostats, the Leica CM1860 and the Leica CM1850. Both cryostats are capable of cutting at 100 microns. Most of the materials required are included in our FD Rapid GolgiStain kit. You will need dry ice, glass pipette, dropper bottle for solution C, plastic forceps, natural hair paintbrushes, glass retriever, specimen disc, gelatin-coated slides, and aluminum foil-covered chamber. Here we introduce the Leica CM1860 cryostat. This cryostat is capable of being adjusted to 100 microns. This is Leica CM1850. Section thickness can be adjusted up to 60 microns. However, we can still cut thicker sections with this cryostat. Please make sure the handle is in the locked position when not in use. Here we show the locked and unlocked positions of both cryostats. First, we'll demonstrate the gluing procedure for the Leica CM1860. Set the cryostat temperature to -22°C for at least 4 hours prior to cutting to ensure the cutting blade reaches this temperature. Press the Peltier element. You'll see the display changes from PE to 10, indicating that the freezing station will provide additional cooling for 10 minutes. Using plastic forceps, place a few pieces of dry ice into the cryostat. In order to begin sectioning, we start by pipetting a small amount of distilled water onto the center of a specimen disc outside of the cryostat. You may also use OCT instead of distilled water for this step. Move the specimen disc from room temperature into the cryostat's specimen disc holder. Carefully align the specimen onto the middle of the specimen disc. Then, with the same plastic forceps, grab a small piece of dry ice and freeze the surrounding distilled water quickly to ensure the stability of the specimen. Now we will demonstrate the gluing procedure for the Leica CM1850. As a reminder, this cryostat can only be adjusted up to 60 microns, but we can still cut thicker sections. Also, adjust the temperature to -22 degrees Celsius. The gluing procedure is the same as the Leica CM1860 cryostat model shown previously. Place the specimen on a bed of dry ice to cool. Using a glass pipette and a natural hair paintbrush, quickly and carefully cover the specimen completely with a thin layer of distilled water. Note that you must act quickly in order to avoid the paintbrush from sticking to the specimen. Here we'll now demonstrate the cutting procedure of Leica CM1860 cryostat. Make sure to push the specimen head back as much as possible. For safety, ensure that the cryostat handle is locked, as well as covering the blade with anti-roll plate and protective blade cover. Then transfer the specimen disc from dry ice into the specimen head. Adjust accordingly and make sure to lock the specimen head to secure the specimen disc. Wait 3 to 5 minutes before sectioning. Uncover the anti-roll plate and protective blade cover to prepare for cutting. Roll the cryostat handle in the clockwise direction smoothly and continuously for cutting. Make sure to lock the cryostat handle after cutting. Guide the sections with a brush onto the cryostat stage, being careful to not touch the blade with the brush. Now we'll demonstrate the cutting procedure on the Leica CM1850. Adjust the section thickness to 50 microns. Push the specimen head back as much as possible. Lock the cryostat handle. Place the anti-roll plate over the stage for protection. Transfer the specimen disc from dry ice into the specimen head. As demonstrated previously, adjust accordingly and make sure to lock the specimen head to secure the specimen disc. Wait 3 to 5 minutes prior to cutting. Uncover the anti-roll plate. We'll now demonstrate the cutting procedure of Leica CM1850 in slow motion. First, turn the cryostat handle towards you in a counterclockwise manner, and stop when the specimen is about 1 mm above the blade. Secondly, turn the handle away from you in a clockwise manner until the specimen is completely sliced. Roll the handle counterclockwise until the specimen is back in its original position. Now we'll demonstrate the procedure in normal speed. As demonstrated, do not rotate the handle completely. Make sure the cutting speed is smooth and continuous. This is a demonstration of the cryostat handle while two sections are being cut continuously. Continue to cut the sections with this technique for the rest of the specimen. Pour solution C into the dropper bottle. These are included in our FD Rapid GolgiStain kit. Using a gelatin-coated slide, apply 1 drop of solution C. With a paintbrush, start to spread the solution thinly, close to the white area of the slide. Then, with a glass retriever, Pick up a section and carefully place it onto the gelatin-coated slide in the location where the solution C was spread. Using a dropper bottle, place 1 drop of solution C on top of the section. With the paintbrush, gently and carefully even out the section, brushing away any excess solution and remove any air bubbles. Again, place 1 drop of solution C in the middle of the slide. Spread the solution thinly onto the next available area with a paintbrush. Continue mounting and cutting the sections in this manner for the remainder of the specimen. Once you've finished cutting and mounting the sections onto the gelatin-coated slides, place the slides into an aluminum foil chamber to dry.
Next, we are going to stain our Golgi sections. It is imperative that sections do not dry out between any steps during staining and before cover slipping. Make sure the sections are protected from light at all times during the staining procedure. First, rinse sections in double distilled or millicule water 2 times, spanning 4 minutes each. Secondly, place sections in 1 part solution D, 1 part solution E, and 2 parts double distilled or millicule water for 10 minutes. Note that all containers containing the working solution must be covered to prevent vaporization of the reagent. It is critical to the staining process that the sections are protected from light. Also, for best results, the working solution should be stirred frequently during incubation. Thirdly, rinse sections in double distilled or millicule water 2 times, spanning 4 minutes each. As an optional step, you may counterstain sections with cresol violet or thionin. We then dehydrate sections in 50%, 75%, and 95% ethanol 4 minutes each. Next, dehydrate sections in absolute ethanol 4 times, each time spanning 4 minutes. This ensures that all water is removed from sections. Make sure to renew the ethanol for each experiment. This step can be prolonged when sections are thicker than 200 microns. The final step of staining requires us to clear slides in xylene 3 times, 4 minutes each. Sections may remain in the final xylene wash for up to 30 minutes if needed.
Lastly, we'll be covering our Golgi slides. For this video, we will be using per mount mounting medium. We have recently discovered that UKIT quick hardening mounting medium by Sigma Aldrich can also be used. We start by taking a cover slip and laying it on a flat surface. Using a glass pipette, transfer some mounting medium onto the cover slip. Using forceps, gently position the Golgi slide with the specimen facing toward the cover slip and slowly place the slide over the mounting medium. Place the edges of the slide on a paper towel to remove excess medium and xylene by tilting the slide several times. Adjust the cover slip accordingly and place the finished slide on a paper towel. Once again, transfer the mounting medium onto the center of the cover slip. With the side of the slide containing the sections, tilt the slide downwards, matching the edge of the cover slip with the edge of the slide. Be sure to tilt slowly to avoid air bubbles. Grab the white area of the slide with forceps and place it on paper towels. Tilt the slide on its edges to remove excess mounting medium and xylene. Adjust the cover slip on the slide as needed. Finally, place the slide onto a paper towel to dry.